So the definition of data is this one: set of measurements on set of recorded values. The set of measurements on set of recorded values, we are calling this as the data. So what exactly meant by set of measurements on set of recorded values? For example, here I'm able to find somewhere around 50 people. So I want to understand about you people. So now what exactly the set of measurements we collected is a psychology test. Let's imagine like name, like your age, or like your educational background, or like your current CTC, or within how many months you are planning for data science. So in this way, we are trying to collect the set of measurements. Just give me a moment. Sorry. Yeah. So we call it as set of measurements. So the name, age, educational background, CTC, planning for data science or not, or from which, what is that company you're working. So all this falls under set of measurements. So now overall, how many recorded values we have it? So now only on this batch, overall, how many recorded values we have it? Roughly around 50 people or 51 people. Is it right?
Yes, sir.
50 or 52. These are recorded values and we call it as set of measurements. And now the data is always called as set of measurements on set of recorded values. It can be a structured data, it can be an unstructured data. For example, now while you are collecting the images of a particular what exactly bike. So now whatever the images you are collecting, it's going to have a specific usage. Is it? Do you collect image of some other bike, or when you are planning to buy one particular bike, so you'll be collecting all the images of that bike? Is it right? The set of measurements like the front view or a rear view or a top view or an interior view or an engine view. In this way, you'll be collecting this type of measurement, set of measurements. So now how many images you are collecting, we call it as set of recorded values. So the reason behind why we need to collect huge amount of data, the more recorded values, is very simple example. Now, for example, let me showcase you one small document. Just give me a moment. Now you are able to see this.
Yes,
So
sir.
don't think about image recognition and all that. Just treat it as a data. Now, whenever you are trying to collect a data, now you are able to see a cat. So which is under a background clutter is also similar to the cat skin. Now within a cat, again, there are different types of breeds. Again, within a dog, you have a different types of breeds. Now you are able to recognize it or not. For example, as a human, for example, when you are a kid, you may be a bit confused. So which is a cat, which is a dog? Again, if the breed is changing a bit, you are confused. But as you're grown up, means as you're grown up in the sense, you're collecting more and more data, means like recorded values of the cat. So you are able to recognize one over the another. So now if you are able to look at an image, for example, now see this. Now, when you are a kid again, for example, based on the change in lighting condition, or if you are able to take your father, he's able to go for a clean shave. You may not be able to find him. You will be finding this guy pretty new. But when you grown up, as you are collecting more and more recorded values, you are able to know this person is my papa, or you are able to recognize with a normal without even knowing it. So now here the difference, what we are doing is when you are collecting more and more recorded values, you are able to get more permutations and combinations. So when you're able to get more combinations, for example, your papa with beard, without a beard, your papa when he is serious and when he is not serious. So when you're collecting more and more data, you're able to see his different kind of scenarios or different combinations of his moods and his appearances, and all this you are able to notice it. So the more data you are collecting, the better your knowledge going to be translated into. Is it right? Yes or no? The more data you collect, the better your knowledge going to be translated. Now, when you don't have the more data, for example, the very simple difference between a fresher and an experienced is what? What is the difference between a fresher and experienced? Can anyone tell me what is the difference between a fresher and an experienced?
Skill set will be different.
The very simple idea, the difference between a fresher and an experienced is, for example, let's take, these are measurements. The measurements remain same for a fresher and for an experienced. But what is varying here? If a fresher is spending time on the same measurements for example, let's imagine like for 100 hours. Now the experienced is spending time on the same measurements for close to, let's imagine 10 years, or he's working more towards 5 years, or he's working more towards 6 years or 2 years. So the more data he's collecting, for example, freshers know there are stakeholders, but experienced people know how the stakeholders moods going to change, what type of issues the stakeholders going to get into our table. So now the freshers don't care about this name, age, and all this. Let's imagine some X parameters. For example, let me write it down for removing that confusion even. For example, there are measurements like you're working on a project. While you're working on a project, yes, you use Python. Even a fresher use Python, even experienced use Python. ML, they use it. Stats, they use it. Maybe Tableau, maybe deployment. For example, there are managers. They're going to be stakeholders, or they're going to be project reviews. They're going to be project deadlines. So these are the measurements. So now a fresher and the experienced, both the people going to address all these measurements. But the difference is, for example, fresher may not experience all this, only he may experience for one time. He may be having one project deadline, or he may witnessed with only one project review, or he may used Python or ML or stats or Tableau, maybe some combinations. He managed one manager or one stakeholder. But experienced people doing the same activity from the last 2 years, or is doing the same activity from the last 3 years or 4 years or 5 years. So the more you are spending time, the more permutations and combinations. So for every project, you are able to use Python, ML, stats, Tableau deployment, or you may change it. And in every project, the stakeholder is going to remain same strict, same headache thing, or they're going to be someone like good and so informative. And all managers going to be like so rule based, or something like the bossy mindset, or they are more friendly kind of environment. So now every time the project deadline is going to be fixed, or it's going to vary. So the project reviews, the nature of project reviews. So from experience to experience, or from project to project, do you get more broader mindset? Yes or no?
Yes.
Yes.
So now these are same measurements, but these are more recorded values. So we are calling this recorded values based on yesterday's concept called as what? Sample. And this we are calling it as what? Features. Do you remember this? Features and the sample.
Yes,
Absolutely perfect. So now the same structure. Now the columns are in x-axis or they are in y-axis? These columns are in x-axis or in y-axis?
y-axis.
X-axis.
X-axis.
So now the recorded values are in
Y.
Now let us go back to this Tableau. Now I will be explaining when time comes for on Tableau. Just now you're able to see two axes here, drop a field, drop field here, something. You're able to see columns and rows. Able to see columns and rows.
Yes, yes,
You're able to see some data here,
yes.
customer name, location, like order, profit. Let me drag customer name into columns. So now it created x-axis or it created y-axis.
X-axis.
If I take the same customer names into rows, now it created
Why?
Y.
now the same customer name when I'm pulling it into columns, now it created.
X.
Now under this X, every time to create a visualization, do you need to have X and Y axis? Now you got the visualization.
Yes.
So x-axis is your customer name and y-axis is your sales. You're able to see in the y-axis sales and in your x-axis the customer name. So every visualization which is constructed is happening between x-axis and the y-axis. But if you look onto the data, there are two colors here, blue colors and the green colors. Able to see that?
Yeah.
Blue colors and the green colors.
Yes.
So we call them as one. Again, let's go back. Now, when you are able to look onto this particular data or the measurements, there are two different types of data. So one is your continuous data and another one is a discrete data. So here we don't find any continuous data. So let us use this. So when you're going back to this data, there are two types of data, discrete data and a continuous data. So age, is it continuous or discrete? Let me explain what is a discrete data and what is a continuous data. So any data which is changing or which is having some units, we call it as any data which is having certain units like meters or centimeters or kilograms or what is that velocity contains units or anything like what is that again calories. So all this comes into what? Units. Or if you take money, there are units like rupees or like dollars or like ringgits. In this way, you have some units. So now when there are units, can you change that units every time? You have that flexibility to change it. For example, you have the time in hours, or for example, your age is in years. Can I translate it into hours? Is it a crime if I translate your age, which is in years, into hours? If I do it, is there any wrong?
No.
Does it change the nature of the data? Not exactly. The same hours data, can I translate it into minutes? The
Yes.
same hours, absolutely. So now in this way, when you are having this, what is that data, the age can be translated from one unit to another unit. You can explain the age in years.
And can you come again, please?
That's what I'm explaining again one more time.
Yeah.
Yeah. So you can explain the age in lines of years, or you can translate that years. So for example, each year comprises of 12 months. So I can translate the years into months. So I can explain the same age in months. So if you are able to take 20 years multiplied by 12, I'm able to translate that in lines of months. So now each month contain how many days? For example, 365 days, or we can say I want each year comprises of 365 days or etc. Again, by multiplying each age with respect to days, I think I'm able to translate it into day wise. So month wise we got it, day wise we have it. And again, I want to translate it into hours. Each day comprises of 24 hours. Again, I'm translating into hours. Now, all the information is speaking about the same age or it is speaking about different ages. When you're explaining it in days, it is giving one age. When you're explaining it in months, it is giving another age. Not exactly. For all the different months or days or all this, it is able to speak about the same age, which you are able to convert it into any level. So the age contains units, so we call it as continuous data. For example, you have your educational background. Can you translate your educational background? Can I convert your educational background, BTech or degree, into some other unit? For example, you've been to some other country. Can you translate it into another unit? Can you translate it? No. So there are no units. We call it as, you have CTC. current CTC. So CTC is in rupees or it is in, for example, or it is a fixed number. CTC, for example, 9 point something or 6.7 LPA. So now every month you are getting, it varies. And again, it contains units. Can you explain it in rupees? Or can you explain it in paisa? Or you can explain it in what is the dollars? Or you can explain it in euros. Can you translate it or it's difficult?
Continuous. Translated.
Second can translate.
Again, it is continuous. Now, when you're planning for data science, within how many months you're planning? So please mute. So now this one, planning for data science, is it a continuous data or is it a discrete data? So planning for data science, what is the question you're asking? Planning for data science is yes or no, or you're asking within how many months? So if it is yes or no, is it a discrete data or a continuous data?
Discrete data.
Yes. For example, if it is in months, within how many months you are planning?
Continuous data.
In continuous data. So now, in the similar way, every data consists of two things: discrete data, continuous data. So now, when the data is continuous, it is in which color? In Tableau. In Tableau, only standalone Tableau. It is in which color? When the data is continuous, it is
Green.
Absolutely. When the data is discrete,
Blue.
now let me pull it. Now you got sales. So what is the amount of sales we got it? 22,97,201 is the overall sales we got it. But how we got the sales? On what basis? So now you are able to get overall sales. So now, for example, I said, hey man, do you know one person got a salary of 50 lakh? Which person may know his location, may know his designation, may know his background, may know in which company he is working? Do you ask these parameters? When I say 50 lakh salary, do you ask this or you just say 50 lakh is sufficient, Kant? I got a complete analysis, or you stop? No. So in order to make this analysis more beautiful, every continuous data need to be verified or need to be dimensioned, or we can say that we need to have a look over how the sales are changing with respect to order year date. So in 2018, how much we got? In 2019, how much we got? In 2020, how much we got? And in 2021, how much we got? If you are removing order date, it is an overall sales. When you are able to drop a order date, it is splitting the particular sales across each and every order. For example, without a continuous data, does this measurements make sense? Do you know there is a guy with this designation, this thing, but I'm not revealing his salary. Can you measure him? Without a salary, can you measure him? For example, there is a guy, great data scientist. He is working in this company. So if you have salary, you can measure his performance. Or if you have some experience, you can measure it. Or if you have some projects, you can measure. So we can't. Now, so every data, so the discrete data and continuous data need to be mixed together in order to grab the insights out of it. So you standalone may not be for some cases, for example, time. So time, is it a discrete data or a continuous data? Than saying time, I say time stamp. Is it a continuous data or is it a discrete data? Time stamp. Time stamp in the sense, for example, now, absolutely.
No,
so time stamp is a discrete data. So why timestamp is a discrete data? For example, now it is right now. So what is the date today? It is 3rd July. So 9:31 a.m. Can I translate it? 3rd July, 9:31 a.m. Can I translate it? Timestamp. At this point, this person bought this product. It is fixed, right? Only one way we have is, rather than making 9:31 a.m., it remains the same. For example, if you are going for PM, maybe you can translate that into hours format and you can say it, but it is a fixed thing. Can you change it? You can't do it. So now the timestamps are your discrete data. That's what your date of birth comes into discrete or continuous now.
Discrete.
Date of birth comes into discrete, and where exactly your age. Now date of birth is a discrete data. In order to measure that, you use a field called as age. So now order date, what happened on that order date? The measure field is sales. So what happened on that particular date? This is the measure field is marketing. Or what happened on this particular customer? So this is what he made, profits or sales. Based on that, I can say whether a customer is a right customer to me or he's not required to chase him around. So now discrete and continuous data rules your entire analysis. Is it clear, everyone? Are you clear with
Yes.
discrete data, continuous?
Yes, sir.
uh,
Yes, Kant.
Yes, sir.
yeah. Yeah. So now here comes one more thing. Data comprises of two different properties. So the property one, there are two types of properties. One, uniform, and another one is a random. The name itself is saying uniform and the random. What exactly meant by uniform data and what is meant by random data? The root of analysis comes from here. Saivam, see the timestamp, why timestamp is a discrete data is it is a fixed things. It's a fixed entity. We can't change that particular timestamp. So that's the reason. And it's, for example, 3rd June. No, can you write 3rd June in any other format? Are there any units for 3rd June, for example? Or 3rd July? Are there any units that I can convert July into some other format?
No.
No.
We don't have any such units for July to translate it. And it's barely encoding, right? You can convert July into 7. It is an encoding. So every month you denoted with 1, 2, 3, 4, 5, 6. So you can encode it. So now you can't actually change it. For example, in the similar way, you have a timestamp like 9:30, let's imagine. So you can't, can you change 9:30 into another unit? Do you have any unit for 9:30?
No, sir.
Right? So it's a fixed thing. That's the reason we are going with it's a discrete data. Got it?
Yes, sir. Thank you.
So now uniform is same data coming and random data is changing. So now where we need to do analysis, when the data is uniform, do we need to do analysis, or when the data is random, we need to do analysis? When we need to perform analysis?
I think random.
Yes. So when the data is uniform, very simple logic. Do you analyze taking pen and paper, and do you analyze at what time a milk packet person going to come and deliver a milk packet? Do you sit on the Saturday night or every night your work is sitting, taking Tableau, analyzing at what time the milk guy going to come? Do you do that analysis? No one do that, right? So now, for example, most of the events which are in our day-to-day life, they are random or they are uniform. Every day waking up, getting ready, going to office, so on time. So all these things, are they random or they uniform? They are uniform. So now why they are uniform? In a very simple note, they are not seriously uniform or they are not seriously random as well. So please mute this. So why they are random? So I'm just muting. So again, when there is a doubt, I will be just making it to unmute. Yeah. So now, what is a uniform or what is a random? The very simple idea behind uniform or random is now there is a kind of pressure on your head. Just imagine your boss may not scold you if you are going late to office. There may not be any problem in your appraisals. There may not be any problem in your things. So when things are not going anything wrong, I think, do you go to office every day at same time or you go in a random way? No appraise, no problem with the appraisals, no problem with anything. You go basically random. So there are situations where things made random. Now, for example, let's take the scenarios which are random. Now, when you are not buying a product from a superstore, is there any crime? For example, people going to send a legal notice to you if you're not buying a products from a grocery store. Do people send a legal notice, say why you're not buying it from last 1 month? No one do that. Or for example, if you are not buying this particular product in Amazon, do they just block you in Amazon? Do they just block you? Hey man, you are not. No one do that. So now that when you don't have a certain rule or when you don't have a certain pressure on top of our head, I think all the things going to be random. So now these are the events which are random in nature. For example, now take sales. It is random. Why? There is no pressure to buy or not to buy. And no one going to question if you are buying or not buying. So it is your pure self freedom and it's your own call. So there is no problem, random. And again, take how many people going to be get affected with a COVID. It's a random. There is no fixed number. There is no targets for COVID virus stating that, hey, for this next week, I think I need to get 1 lakh people. On the next week, 2 lakh people. There is no targets for COVID virus as well. So now again, it's random. So when the things are random, can we seriously, accept that randomness, or you want some predictions? For example, you came near me, Kanta, whether I get a job or not. I said, man, see, you are learning statistics, you people are matured enough. So now it's a random data. How can we say whether we get a job or not? It's a random thing. You may get or you may not get. No one going to join the program. That's where I need to sit. I need to analyze the patterns. See, man, I think you are from this background. I already got this type of people, which I trained them. I made them to place with similar kind of thing. So I can say, yes, there are chances, means like if you are able to do like this, yes, you are able to get a job. So now I'm trying to analyze it, to reduce that randomness and to create that projection towards the future. That is the actual goal. Is it right? If I'm unable to solve your problem towards the future, you can join near me. Can you join? If I say it's a random data, it's like uneven thing, so I don't know whether you get a job or not. Actually, it may not be possible. So what exactly people are doing right now is, for every random event, they are trying to analyze it. So people are getting COVID. They are not stopping. It's a random thing, so we can't do it. So they are analyzing why the COVID is coming, how it is outbreaking, what is the reasons, what are the patterns, and they are trying to fix that randomness. They are able to understand, than saying fixing, they are able to understand the randomness. So when someone can understand the randomness, can they fix it? When someone can understand the randomness, can they fix it? Absolutely. So now if I'm able to understand the randomness of why a customer is not buying or why a customer is buying, if I'm able to understand this, can I make sure that every customer is able to buy it? Absolutely. Why people are investing a lot in, for example, if you take neuromarketing is a field where we are using computer vision. So now they are using it, for example, at what positions we need to place the advertisement. So what we need to place in the shopping mall, at what entrance of that, what we need to place it. So again, it is decided based on what demographics, in which location we are in, what are the nature of the people. Based on that, we are trying to design the shopping mall. So we are trying to understand the randomness, so we are able to grab, or we are able to capture the customers. That's what people are doing. It's not only with this. For example, weather report. So weather report is all about, again, understanding the randomness of the climate. Yes or no? Are we trying to understand the randomness? Absolutely. So now it can be health. So are we trying to understand the randomness by watching YouTube videos, by watching various content on diseases, on diets and all this? We are trying to understand the randomness and we are getting a grip over it. And after COVID, I think most of the people got this health education or diet education. Is it right? You're not having an education towards what to eat, what not to eat. So what exactly need to be delivered to a body. So all this knowledge, most of the people got it. So why? Because of YouTube, they keep on searching it. So they are trying to mitigate the randomness. So now what exactly you people are doing? We all do the same thing in our day-to-day life. To buy a phone, to buy a bike, to make any decision, you try to understand the randomness, so you are able to make a decision. So, but in data science job profile, what you are doing is a small difference. What you are doing in your day-to-day life, so you are trying to understand the randomness of the company. Randomness of company. So what is the randomness of the company here? So every time the randomness of a company, is it linked up with things which are connected? Every time company is connected. Company is just a kind of shallow thing. There is nothing inside. So until and unless you place something inside a company, if you are able to place people, I call it as employees. Or when I place some stakeholders, for example, I'm getting some products from this guy or from there, or I'm having something like customers, or I'm doing in this company marketing, the same thing I explained on yesterday. So there is some IT department within this company, or there is some operations within this company, or there is finance in this company. So now, is it a deal for a company to control all the randomness across all these divisions? These are all the things which are connected with a company. Is it required to understand the randomness and to fix it, so that the decisions they are making are purely under their own control? So is it something needed for a company? Take a healthcare, take a manufacturing, take an oil and gas, Take any company. So everywhere you have the randomness, isn't it? Absolutely. So we have the randomness across every division. So what a data scientist is doing is, so he's trying to understand the randomness of the companies which are connected with. So the elements which are connected within a company, or the processes which are connected with a company, by using the tools. What are the tools? By using Python, or by using your ML, or by using deep learning, or by using time series, or by using your, what is that? Tableau, or by using SQL, or by using your deployment. By using all these tools, you are trying to understand the randomness of the companies so that the companies are having a connection over the activities which they are doing. Is it clear, everyone? The root of your analysis, why this analysis came into the picture, or why this job roles came into the picture, everyone? Perfect. So now, let me move to another thing. So as we are discussing, so this is the root of statistics. So the statistics says, in the statistics, there are two types of data properties: uniform property and a random property. And apart from it, again, data comprises of, again, we need to understand data sources. There are two data sources. So one type of data source is experimental. The name itself, it is so easy topic. Another one is observational. So what is the difference between experimental and observational? You can use the chat and you can just type it. I'm seeing your chat. What is experimental and what is observational? Observational is randomly taken from the existing market. Okay. Okay. Let me explain what is experimental and what is observational. So now the data which I'm generating right now in this Excel sheet, for example, there is an Excel sheet. So this is what we used on yesterday. Is it able to grow by today, or does it remain same? Is it growing or it is same? This is the data which I created on yesterday. Is there any proof that we created it on yesterday? Is there any growth in data? Any new data generated automatically? No. So this is experimental data. So experimental data is purely created by the user, and he has the entire control over the data generation process. So if I create the data, it's going to be generated. If I delete the data, it's going to be deleted. Let's take an example like Facebook. Now the data generation, is it in the control of Mark, the founder of the company? Is he in the control of the data generation? Is he in the control of the founder? Can he control the data? If he start controlling the data, the only way to start controlling the data is he need to shut down the Facebook, or he need to shut down the entire Meta. Only then he can control it. Is it right? Absolutely. So now, if you go back to Facebook, if you look on to Amazon, if you go back to any company, the data generated mostly in a company from the customers, is it an observational data or is it an experimental data? Sorry, some network. Able to hear me? Once confirm me. Am I audible? Yeah. So now when you're able to take these examples like Amazon, Facebook, and all this, the data they are generating is observational data. Now, the jobs which you're trying, is it an observational data or is it an experimental data? For example, you're going to the job requirements which are posted in Naukri or the job requirements which are posted in all this. Is it an observational data or is it an experimental data? It's an observational. Do companies wait for you until you get completed with the training, or they change the requirement based on the need, or they just wait, hey man, this guy is learning data science. Let's wait for next 1 or 2 years. He's doing some PG program at some. So let's wait for 2 or 3 years. So the challenge here is the observational data is keep on growing. So you are staying stagnant for 2 years, or you are staying stagnant for 1 year, and you are learning the content, and you need to compete in this particular observational data. So you need to compete, means like whatever the knowledge you have here right today, it may not be sufficient to stay there. So you need to automatically update it. So that's what happens, experienced people. So the day you join and the day what you are today, I think your knowledge is grown. The tools you use are different. So are the everything what you are doing right now in your job are something which you learned in your BTech or in your degree? Not exactly. So now you do this learning curve and then you get into this observational thing and you do. This is what happens. So now when the data is observational, then what is the nature it going to have it? When the data is observational, what is the nature it going to have it? It's going to have random. So that's the reason you're asking me, Kant, if I'm doing data science, so how long this job profile going to stay secure, or how long this job going to have the demand, or how long this skill set going to make a sense in lines of my real-time job get in order to get a job. So you're asking me all the questions you already know. Let's say observational data, whatever the skill I'm learning right now, does it going to be sufficient or not? You have all these doubts. So that's what I'm trying to break it through my randomness. That's what I'm trying to analyze it. So now, for example, a company is trying to manufacture a product. So our company is trying to sit on a research. So now do they need to analyze it? Whether before we are completing this research, other products going to release that item or not? Do we need to do that research so that our research money is not into the waste? Absolutely. You need to go for a research. Again, observational data need to be done with a randomness. We have it. So we are doing analysis. So what is an experimental data? For example, like I said, on yesterday, what is that phenomena? Or for example, I'm conducting some experiments in my company. Maybe I'm just loading the data based on the experiments I'm conducting. Again, all this comes into observational or experimental. The experiments which I'm doing, or some tests I'm doing, some kind of random things I'm calling, some mock interviews I'm doing in my interview, all this comes into experimental data. So these are the two different data sources: experimental data, observational data. So now, is it clear even this concept, everyone? So now we discussed about three things: data definition, we discussed about discrete data, continuous data, property of a data like uniform and a random, and the source of the data, experimental and observational. Is it clear? Perfect. So now here comes another topic which we are going is called as sample and a population. Observational data is random. So why it is observational data is random is, do you have a control over the data generation, Akshat? Do you have the control over data generation? So when you don't have the control over data generation, can you expect what going to be on tomorrow? When you don't have the control over data generation, can you expect what going to happen on tomorrow? What type of customers, for example, do Mark has the control over Facebook in data generation? The answer is no. That's the reason. Can he imagine who going to use bad words in Facebook as a status? We can't expect everyone going to use Facebook for the good words, right? Some people can use it for wrong things. Some people can use it for good things. Some people can use it for different things. For example, when Facebook is created, so a lot of business people started using it and they started marketing their content. So now that's where again, Facebook for business is a separate wing they created. Initially, they created as a social media thing where just to interact, to chat and to engage with the people. But initially, business people thought where there is more engagement, we have this. So it's keep on engaging. For example, someone can copy another person's image. We can't expect like everyone create a genuine image. We can't expect it. There may be some fake images. So now Mark need to create the solutions internally within Facebook, which can beat that issues. So if Facebook need to have that intelligence in order to identify the wrong words. So all these things need to be done. That's where I think it's an observational data. They are analyzing that randomness and they are coming up with the right solutions which can fix that randomness. Got it? Experimental is random. For example, at some cases, what are the results we are getting, but the data control is in our own hands. Got it? Yes. So now here comes a small concept called as sample what is sample and what is population? Can anyone just give me an idea? Now we are discussing another one, sample and population. To the entire population. Again, sample and population is purely in lines of analysis. So can we access entire population? So what is sample? What is population? Now my voice is clear, everyone. Now my voice is clear. Yes. So now what is a sample and what is a population? So now can we access entire population? These are the two questions. Can we access the entire data, Seema? I think you said population is a total data. Can we access the entire data? Maybe not. Okay. Let me just give you the things. So sample and population can be explained as, so sample is approximately equal to population. So sample is approximately equal to population in lines of properties, but they vary in sizes. So for example, if the sample size is 10, for example, then the population may be 100, very huge. For example, now you all are aware of what is the average salary of a data scientist? Can anyone tell me what is the average salary of a data scientist? Average salary of a data scientist? 7 LPA or 8 LPA. Now, are we able to collect the data across every data scientist across the globe? Have you been to every data scientist across the globe? went door to door, asked them, hey man, what is your salary? Taking an Excel sheet, loading everything. You traveled across the world. You are a world traveler. So been to every location, every minor thing, every data scientist. So no data scientist is out of your sight. Every data scientist you collected, it's not. So now you're able to access the population now to make a statement about population. So we are unable to access the population. So when you are unable to access the population, what you are trying to do with this theory, so sample is approximately equal to population. It is not completely equal to, it is approximately equal to population. So you collected the sample and you started analyzing this sample, and based on that, you made a statement, the salary is 8 LPA or etc. Is it right? If I'm not wrong. So in order to have this concept, people use one more concept called as CLT. We call it as central limit theorem. What exactly central limit theorem states that population mean is equal to sum of sample mean or average of sample mean. So what exactly central limit states that population mean is equal to sum of sample mean or average of sample mean. So now every time, what exactly we are doing? The same thing. For example, now if you want to make a statement about what is the data scientist salary, average salary, you try to collect different samples. You calculate the average sample means of different samples. For example, you've spoken with some friend or you've spoken with some other guy. Based on all this averages, you try to say this is the accuracy or this is the average salary of a data scientist. Is this the way you try to say? Is this the way how you make a statement about the population in your day-to-day life? For example, you want to make a statement about one of your friend. So you try to take his behaviors across different intervals and you try to make a statement, this guy is more like this. Is it right? Go for a bike. You want to buy a bike. Again, you take few samples and you make a statement, this is how the bike going to look like, right? So now what we are doing, we are using one of the concept here called as central limit theorem. What is central limit theorem states that? So population mean, we can't analyze the population mean. That's the reason in order to analyze the population mean, you are using this right hand side. How you can calculate a population mean based on sum of sample means or average of sample means. So by calculating either a sum or by taking an average of sample means, I'm able to make a statement about the overall population mean. So we call this concept as what? We are calling this concept as what? Central limit theorem. But here comes the challenge. So what is the challenge we are able to get here, Kant? For example, everything is so good. We are able to go for a population mean. We are able to collect a sample mean. We are doing this in our day-to-day life. So when you're doing this every day in your day-to-day life, all your analysis are right. Every analysis which you made about the population, is it right? What do you say? Every analysis you made, is it right? Practically, it may not. The reason here, in order to take your analysis to go wrong, so there is only one way that your analysis is going to be wrong. What is that only one way your analysis is going wrong? The techniques you are using or what? Absolutely, that's right. So the sample which you collected is completely wrong. So when you're able to collect a wrong sample, it indirectly creates a wrong analysis on top of your population. Is it clear? So now we are studying the same thing. In order to pick a right sample, there is one more statistical technique, which we call it as SAC. What exactly SAC is called as statistical analysis consideration. If you want, you can note it down. What is SAC? Yeah. So again, let me repeat one more time. What is central limit theorem? Based on the central limit theorem states that population mean is equal to sum of sample mean or average of sample means. So when you need to use this condition is when your population is incredibly large. So what exactly meant by very huge in sample size? So when you're unable to calculate the mean of the population, it is incredibly large. So which is called as, then you need to use central limit theorem. For example, your population, you are owning a company and you have the company across two branches. Now, is there any need to calculate a population mean or the central limit theorem? Now you want to know what is the sales of this company across the two branches. Is it required to use central limit theorem? Is it required to use central limit theorem? It's not required. Why it's not required to use central limit theorem is it's like very simple data. You have only two branches for this company. You calculate the average sales or overall sales happened across two branches. You sum it up. That is the overall sales of the company. There is nothing to go with a central limit theorem. Just imagine you are having a very big company where you don't even know its footprints. Let's imagine you don't even know where the footprints are. Then what you do? So you will be collecting the data across the locations which you have the access. Okay, I have the location access to India. I got some location access to Australia or to something like UK or some USA. I collect only the data from that locations and I project this may be my overall population sales. Why? I don't have the access to all the locations. I got only few access. This is what we will be doing it. So like the same thing when you are going with your data science salary. Now data science, do you have the access for all the data scientists across the globe? Can you go to door? The same thing I asked. Can you go door to door and can you ask the data science salaries? Not exactly. That's the reason the access you have it. I got 10 people or I got 100 people. You collect the data from that 10 or 100 people and you say, this is the salary of a data scientist. You stay in that imagination. You stay in that numbers. Is it right? So that's what the central limit theorem is saying. Got it? So we are all are using central limit theorem, but we don't realize it. But this is a central limit theorem which you are doing in your day-to-day life. Clear, Kaushik? Yes, sample and population are same in lines of features or properties, but they vary in sizes, right, Kushal? That's right. Yes, we are taking mean or you can take some. You can take mean or sum based on the problem statement which we are doing. Now, if you take sales of a company, it can't be average. You want to take sum of sample means. Now you want to make a statement about what is the average salary. Now average of sample mean. Based on the problem which you are going with, you need to choose between sum or average. Meanwhile, I not yet started with SAC. I will be explaining right now what is SAC. We are still at central limit theorem. So everyone, is it clear? Central limit theorem, sample and population concept. Is this clear? Perfect. So now let's go with SAC. SAC is called as Statistical Analysis Consideration. So let me write it in another new one. Just give me a moment. So now we are discussing about SAC. So why SAC? I already gave the answer. Why SAC? Why SAC? Absolutely. So SAC major purpose is to pick the right sample. In order to pick the right sample, you are using SAC. So now there are steps within this SAC, statistical analysis consideration. First step is purpose. Purpose of your analysis. Why you are analyzing it. So in a very simple note, I call it as why. So second is document your questions. So based on the way you are questioning, so do your purpose changes? Yes or no? The way you are questioning, do your purpose changes? Absolutely, it changes. Based on the way you are questioning, the purpose going to change. Just imagine, now you came to a training institute and you are asking about the questions on how many hours of training it going to be, or whether they are able to provide me recording content or not providing a recording content. So maybe like what are the different certificates you are providing and all this. Is it about job or is it about learning? The questions you ask, is it about job or is it about learning? It is basically about learning. It's not about job. So for a job, you need to ask different set of questions. Is it right? Now, when you are planning to buy a phone, again, the way you are questioning it, does it change? For example, you are asking a phone about camera, about display, about the battery life, about something else, let's imagine. So now you're mostly concerned about camera features, camera and all that. So now your purpose of buying a phone is for what? For camera. Now you're asking about security. You're asking about privacy. You're asking about the speed of the phone. You're asking about multitasking abilities. You're asking about pen tool and all this kind of thing. Then your usage is for primarily for a business, right? So you're more concerned about, for example, the colors, aesthetics and all that, or the branding and all that. You're more concerned about like showcasing some status feel. It differs based on the way you are questioning. Does it change the way of your analysis? Absolutely. Now, after documenting your questions, you need to identify your POI. So POI full form is population of interest. Now, I will be giving you one simple example of document your questions. I will be telling you. So now, for example, if you go to the internet and if you search benefits of smoking a cigarette, do you get benefits or you get side effects? Basically, man, you get benefits, man, when you're able to go and search for benefits of smoking a cigarette. Even there are some people who write benefits of cigarette, right? There are some benefits for cigarette as well, I think, right? They'll be writing few benefits. If you're not only with this, for example, drinking a beer, do you get benefits or side effects? I want benefits of drinking a beer. Do you get benefits or side effects? Whatever, if you're going to the internet and if you search for benefits of doing a murder, even some people going to write benefits stating that it's going to relieve your stress, it's going to be reduced with your heart rate. Why? In the sense you are having lot of tension on one person, so by killing it, it's going to normalize it. In this way, some people going to write it. So now the way you are questioning it, the way you are analyzing it, it's going to change the view of a particular thing. Is it right? Now, based on the way you are questioning, automatically changing. So we call it as population of interest. rather than going for smoking, drinking, and all that, let me go for phones itself, for phones or etc. So now, what is your population of interest? Let's imagine you are going for a data science job. You are located in India. In India, you are specific to Bangalore, or you are from Pune, or you are from Mumbai. So your population of interest is from where? Or from Kerala, right? Ashik, I've been to Kerala last month, Ashik. So now your population of interest. Now I gave examples. If for example, you want to analyze the salary of a data scientist. Let's imagine data scientist salary. So now you have the questions documented. Let's imagine these are the questions which you need to ask. So now what is your population of interest? So now you need to understand the data science salary. You have the questions, and these questions need to be asked across India, or the data need to be across world, or it need to be from a specific location like Bangalore or like Mumbai or like Kerala or like Pune, or from which location you want it to be. You want that to be specific to across India, or you want to be more precise about it, your population of interest. Let me take my example. Now, for example, I want to be more precise. I'm from Bangalore, so I collect data science people. So my population of interest is from which location? From Bangalore. So again, within Bangalore, I'm from which background? I'm from mechanical. So what is my experience? 5+ years, let's imagine. So now my population of interest is I want people in Bangalore who are mechanical background and who are having at least more than 5 years of experience. And these people need to be what? These people need to be data scientists. Is it right? So I need to collect data scientists in Bangalore location who made their career from mechanical and they're having an overall experience of more than 5 years. So these are the people I want to target. On this people, I want to ask the questions. On this people, I want why I'm doing the analysis to know the data science salary, or to know the data science skill set, or to know the data scientist job journey. To know this is my population of interest. Now, again, in this population of interest, can I find a lot of people? Again, can I find lakhs of people within Bangalore? I can find again lakhs of people within Bangalore. So now can I contact all the lakhs of people, or I want to pick a sample? Collect this sample based on POI. So you are trying to collect the sample based on the population of interest. So now where the things going to go wrong, I will be highlighting you. So where we always make a mistake is at this zone. So can you tell me where are the areas we make the mistake? I feel this is the point where you make the mistake. You don't basically decide a precise analysis. You may not be knowing the right analysis. You never know the right outcome of the analysis. That is the first mistake we do. Is it right? And even, do we seriously document the right questions? For example, do we seriously document the right questions? Obviously, when you are unable to properly collect when you are unable to understand the actual goal of your analysis, the documenting your questions also going to be a bit wrong. So again, can you seriously collect the right population of interest? The precise population of interest, do you collect it for your analysis? Say yes or no. Do we collect serious the right precise population of interest? Again, the answer is a bit no. We may or we may not collect. So when about 3 things are going wrong, the 4th step going to be right or wrong? It's going to be obviously wrong. So now, as I said, the topics which we discussed from the morning till now, all the topics are something we are doing it in day-to-day life. Is it right? Are the things which we are doing in our day-to-day life? So now, as I said again, these are the topics are the discipline. So now by knowing about these topics, we are making our analysis more aligned for the future. Is it right? So now from the next time when we are doing an analysis, you will be having this awareness, this discipline, based on that you start doing it. Is it right? Now, by learning the statistical analysis consideration, now you will be having whenever you are trying to buy a house. So what is the purpose of your analysis? So for example, let's take our day-to-day activity. So now buying a house, for example, let's take one task right now in class task, buying a house. So for the buying a house, can you write down purpose of your analysis, document your questions, identify your population of interest and collect the sample not required. I think population of interest, if you identify it, only we are picking some sample from that population of interest. So the 3 points, can you write it down? Purpose of your analysis in order to buy a house. Based on that, I will be giving you some corrections where you made a mistake, where it need to be corrected. Can you do this? In order to buy a house, what is your purpose of your analysis? Document your questions, identify your population of interest. Kunal, documenting the questions is like, for example, you collected purpose of your analysis is like as a buying a house. So in order to buy a house, what are the questions you need to ask from the sample you collected? For example, it's there, Kunal, you already bought a house. For example, what are the questions I need to ask Kunal? Hey, Kunal, where you bought it? So what is the pricing you invested? So how you decided this is the right place for you, or how exactly you are trying to, how the right price you decided. So how you bargained with him. So what is the process of the loan you went through? How much you made as a down payment? How much you got the loan amount? So from which bank you got it? This are all comes into what? Documenting questions. What to be asked on a sample is called as your documenting your questions. Got it, Kunal? Yeah. So now the 3 things, write it in one notepad and send it at a single shot. Don't send it in 3 different lines. So send it in 3 different, all the 3 noted in a notepad and send me that all the 3 things at once so that I can have a look over in an easy way. Same chart itself, Joseph. I'm seeing your chart, right? You can write in notepad, just send it in the chat, just copy that thing which I have written, paste it here in the chat. Akshit, you have the interview preparation group, right? I think you got the link, I think so, interview preparation group. Just give me a moment. I'll be back in 1 minute. You can, so I think while you are, so can I share some comments on your answers? For example, like comments in the sense corrections. I think you may not be feeling it bad. Can I do that? Again, I'm taking permission from you people. Yes, absolutely. Then go for it. I will be doing some cross-checking, cross-verifying. So please post it over the chat. I'll be back in. Now the time is 10:20 to think. Don't do it very quickly. Think. Do it by 10:30. Okay. So think and do it. So for analysis, the more time we spend is on thinking. So the same thing, Pawan, purpose, document your questions, identify your population of interest. So on buying a house. So for buying a house, what is your purpose of your analysis? What is the documenting your questions? Yes. Okay. On the same thing, whatever the answers you posted, I will be commenting on top of it. So in lines of in-depth analysis, like cross questioning. Okay. So I got few answers. Let me just so let me share my purpose for the same problem. Let me share my purpose of your analysis, my documenting your questions, identifying my population of interest. Let's imagine, let me share mine as well. For example, my purpose of analysis on buying, for example, house. For example, why I want to buy a house. Is it for my living, or is it my future? Or is it just to have a feel of own house, or my family is saying me to buy me a own house? So what exactly is my purpose of my analysis? For example, my why I'm buying a house, maybe for the sake for my kids, or for the future, basically for the kids, or for I'm not planning to live, or I just want to give it as a real estate. May not be a house again, or for example, why you are buying a house just to rent it out. So these are the questions, more precise way of questions. Okay, I want to buy a house. Why? For example, to rent it. So in order to rent it, for example, what are the documenting your question? So if I am planning to rent a house, why in the sense that is not for me, not for my living. I am buying a house for my kids, so that until my kids are able to be at one point, I'm just want to use it for the renting sake. So for that reason, it is working like temporary money, like 10,000 or something. But again, for example, if I want to go deep into it, I'm a business person, then every month EMI which I'm going to pay, for example, if it is 20,000 and getting a house rent around 10,000, let's imagine this is the EMI and this is this. So the worth of this house may be like 60 lakh. And this one, what I will be getting, for example, 10,000, for example, if it is for 20 years, maybe like 20 or 30, I'm getting half of the amount. So now, again, in case if I want to be more mathematical, I may go or I may not go. So based on these numbers, I look for, okay, let us reduce the EMI further. So the house price should not be even more 60 lakh. Why in the sense for a 2 BHK, people going to take a rent for only 10,000, and we are buying it not for right now, we are buying it for the future. So we can reduce the pricing less, even we can go for an EMI even more, a bit less, so that it going to make my burden less, and even I don't feel this investment is waste of money. So that's how I'm going for it. So the documenting question is first, based on this analysis, it is not falling into my requirement. So I want to reduce my EMI and I want to reduce my things. So now I want to identify what are the questions I have at my requirement is. I want a house at a least price, at a best location, at a least EMI. Why in the sense this is not for me, this is for a renting sake. And when I'm renting, this location also need to be in a position where people are more willing to come and to rent it. So now again, what are the rents across that area? Why in the sense I'm buying a 2 BHK, for example, across that area rents are 5K. And if I'm buying an apartment and giving a rent for 10K, no one going to come. So what are the areas or what is the rents across that particular surroundings? So now who is the dealer? For example, if I'm going with a person who is selling me an apartment, who is the dealer? What is his track record? So what are the various previous projects this person done it? So now again, do I have any contacts? Why in the sense now this dealer's going to sell different prices for each person. So do I have any contacts of the people who recently bought it over there, so that I can verify at what pricing they bought it? Again, what are the amenities they promised for us and what are the amenities they promised to them? So now again, is there any differences or they're cheating on us? So again, what is the material they used it in order to buy, in order to construct construct that building. So again, for example, if I'm trying to sell it out, what is the amount of land I'm able to get it from that particular apartment? So this is the kind of questions I have it. So now based on these questions, now what is your population of interest? So now my population of interest is I'm located in Bangalore. So I want in it Bangalore, it need to be a 2 BHK, and the area need to be something based on rented location where people need to come and need to take the rent. So it need to be close to the rental things. So, and what is the population of interest? Is it is it still in construction phase? Is it constructed, about to occupy? Or is it the phase is not even started? It is still at the land phase where they are selling the lands. And in the future, an apartment going to come. What is my population of interest? The apartment which I'm buying is not for my living, it is for my future kids. So now I want to see something from the land stage, or already they started the basement, or they are still at the construction stage. I want to buy either a construction stage apartment or still a land stage. That is my population of interest. So based on this, I want to collect, again, I'm collected the data about various builders across Bangalore location who are very good, who have a very good track record in lines of money and in lines of lesser amount of investing and the best amenity providing and all that. So I collected only these people, and from this I collected the sample and I started analyzing it. Got it? Clear? Purpose: document your questions, identify your population of interest, and collect the sample. Right? So this is the way basically we do it. Now, here, if you understand, the depth of my analysis is purely dependent on these two things. If you look onto it, if you are failed at these two things, if you are very light at these two levels, the entire analysis is going to go in a wrong direction. So that's the reason every time this why is very important. Clear? So once you got the data, then what you do? Once you got the right sample, then what you start doing it? Once you got the sample data, what you do? In a very simple note, you start analyzing it, right? And most of the people who submitted it is like good, but for cross-checking sake, I just gave my solution. Whatever you done, it's good. Okay, but even I just made it into my analysis as well. So yours is also good. Got it, everyone? Now let's go for analysis stage. So before going for an analysis, before discussing about analysis topics, let's create a small mind map on the topics which we just discussed it. Population of interest is what you are trying to collect from what you are trying to look. As I said, population of interest is like I want to buy a house. Again, if it is like an apartment, or in a very simple note, in a phone. Now, which phone you want to buy? For example, let's take an example like phone. Which phone you are more willing to buy? Android. So at what pricing you want to buy? $25K or $45K. Now, what is your population of interest? You want phones around $25K, and from population, from the which one? From Android. That is population of interest. And in a very simple note, the population of interest is more like filters in your Myntra. You are aware of filters, right? You can sort, not sorting, filtering. You're filtering it based on a brand, based on a specific price. Do you do that in Myntra or in Amazon? That is your population of interest in a very simple note. Got it? So today we started with statistics. Is it clear, everyone? So we discussed about data definition, and the definition of data is like set of measurements on set of recorded values. So after that, we discussed about data types. So it comprises of discrete data and continuous data. And after that, we discussed about data properties, where we discussed about what are the data properties? Uniform data. Another one is random data. So after data properties, we discussed about data sources. What are they? Experimental, observational data. So when the data is observational in nature, it's going to have which property? It's going to have a randomness. So when your data is having random data, then what to do? We need to perform must understand the randomness of our data. So how we can understand the randomness of our data? Through analysis. So on what data you try to perform analysis? So you're not through analysis. So on where you try to do the analysis? On sample. So this sample is dependent on how to pick right sample through SAC. So what are the stages in SAC? Purpose of the analysis, document the questions, identify the population of interest, collect the sample. Is it right? So now, is this the chart we learned all this time? Is it clear? Now see this. Is this what we discussed? So I will be sharing this mind map as well. SAC statistical analysis consideration. Statistical analysis consideration. Okay. Why to analyze a uniform data, Vamsi? It's already uniform, right? What is the need of analyzing it? The simple example is, we analyze a milk packet guy? When uniform data is converted into a random, then you analyze it. So here, so after collecting the samples, then we try to perform. Got it? So once you collected the sample, you try to go with either a descriptive analytics or a predictive analytics or a prescriptive analytics based on the purpose of the analysis. Clear? Perfect. So any doubts, if you have, you can ask me. So documenting the questions in the sense what you are willing to ask on a particular thing. For example, now you are planning to buy a product. Let's take filters in Myntra. You want to buy a dress from some X brand at a pricing for this one. So, but why you are buying this? So why you are buying this particular product? So why you are buying this particular dress? Is it for a wedding? Is it for a casual? Or is it for just buying it for a wedding? Or you are just buying it for a workout? Or you are just buying it to show off? Or you are just buying it for a business wear? For what you are buying it? Why you are buying it? So the purpose. So than saying a purpose, the questions you have it in your brain. What to be, for example, now, what is the purpose of your thing is like, I want to go and I just want to buy it for a wedding. So again, in a wedding, what are the questions? So do I need, how I need to look like? For example, in a wedding, do I need to look like a Shah Rukh Khan? Or do I need to look like this person? Or do I need to look in this tradition? Or do I need to look on that tradition? Or do you have any role models in your brain? Or do you have any, fashion people in your brain? You want to look like them. So based on that, these are the questions you have it. So these things where I can find it, in which brands I can find it. So in which population of interest, means like at which brands, at which pricing. For example, I want to look like a Shah Rukh Khan, but his suit is worth like 1 crore. But do you have your interest within 1 crore? Can you invest 1 crore on a suit? 10,000 or 20,000 or 15,000. So you are pricing the population of interest from which brand. So for example, you are located in Hyderabad. So the brands whereby Shah Rukh, can you get it here in Hyderabad? No. So now within the brands you have it, within the particular pricings you have it, you are searching for the purpose which you have it, within the questions you have, you are searching within that. Got it? Yeah. Even this is also experimental data is more like, for example, you go to chemistry labs, there you note down the recordings and all that. It's experimental data. Or I'm doing some analysis here. I'm just collected a few people and I'm just analyzing your people behavior, how exactly you're understanding the feedbacks I'm collecting from your people. Experimental data. So now whatever we discuss is not analysis. If you notice it, is there anything here analysis? From morning till now, have I spoken anything about analysis? It's not about analysis. It's about definition of data, types of data, properties of data, then how to collect a sample. Once you collected the sample, that's where your analysis is starting. See this. It is also a purpose of analysis or problem statement. So once you have all this, you collected a sample. From there, you are going with any of the three things: descriptive, predictive, or prescriptive. So from here starts analysis. Clear? Right, Seema. Experimental data can be random or it can be uniform. It can be both, but it's a very small data. So even though it is random, we don't care much. So we can analyze it. Why? It's a very small data, but you're focusing more towards analysis on the bigger things. So Kushal, when you are unable to get the proper answers, and since until you get a proper answers, you keep on doing the samples, right? You keep on going through, refer multiple samples. When you're unable to get a proper answers to your questions, the problem is you don't have a right sample. There is no rule that for every problem you need to have a right sample, right? Do you have the right data for COVID initial days? Do we have the right sufficient amount of data for COVID? How COVID came? All these questions, do we have it initially? In 2019 or 2020, do we have this complete information? No. So as you are, but you are keep on doing the analysis, you're not stopping until you get a more data, you're keep on doing it. That's how it is. So now see, Abhinash, it is not a fixed structure. If you want it, you can follow this. If you don't want it, you don't want to follow this. It's up to you. It's complete a choice of a data scientist or any analysis. This is a procedure, or it is a kind of discipline to go for it. Population of interest is like filters in your Mintra in a very simple note power. So population of interest is from what you are trying to buy, or from where you are. For example, you want to know about data scientist salary in Bangalore. By instance, you are planning to work in Bangalore location. So you want the population of interest from Bangalore itself. That is population of interest. Or you want to buy a brand, you want to buy a product from a specific brand. That brand is population of interest in simple. Yes, Akshat. Population of interest is based on purpose and document. Means it's like documenting the questions. Absolutely right. So as I said again, this is a discipline. If you want, you can follow it. In case no, I don't want all this directly, I go to descriptive, do it. But once you have this knowledge, the way you collect the sample, does it change or not? Once you have this knowledge, the way you collect the sample, the way you do the analysis, does it change or it remains the same way? I'm asking you, when we are collecting the when we follow this procedure, does it alter the way you do analysis or it remains same, like normal way we are doing it in our regular day-to-day life we do, and the way we do like this, does it seriously impact it or it remains same? So even though you follow the procedure, if you are unable to go with a proper purpose and if you are unable to go with a proper questioning, your analysis remains same. Got it? So your entire analysis is dependent on the purpose and you're documenting the questions. The better you are able to go for it, the better you can analyze it. So your entire analysis is on this first two steps. So that's the reason the way you analyze, that's the reason I gave a very simple example. So the questions you ask, basically, or for example, the purpose of your analysis, you don't care much. For example, you give a call to trainer or you give a call to sales guy and you ask questions about the course. Why? In the sense, all the questions which most of the people ask me are related to course itself. Very few people ask me about job, and most of the people are concerned about learning. But there is a difference between learning and getting a job. So all learnings may not lead to job. And all jobs, for example, the questions you are asking for jobs, to get to a job without a learning, can you get a job? Without a job, without learning, can you get a job? So you don't get it. So now when you are directly questioning about a job, in the sense, you are focusing more with learning as well, right? When you're questioning everything about it with respect to job, in the sense, you are incorporating even the particular learning as well within that analysis, right? So the purpose of the questions or your analysis need to be so well defined. That's what we call it in Six Sigma. If you want, you can try this technique. It is out of the course. It is not related to this. We call it as 5 why technique. So anyone are aware of 5 why technique? Anyone here are aware of 5 why technique? For example, let me explain. I'm unable to get job. So this is a problem identification technique. 5 why technique is a problem identification technique. So now I don't know what is the problem. I'm unable to get job. Again, why? So why you are unable to get job? Another first why. Why you're unable to get job? Why you're unable to get job? Maybe. So for example, no skills. No skills. Then again, question, why you don't have a skill? Why you don't have a skill? No interest in learning. Why you don't have an interest in learning? Hard to understand. Why hard to understand? No proper resource. For example, let's imagine no proper resource or tutor or no proper guidance. Now, what you need to fix in order to achieve this? What you need to fix it? Now, if you are able to fix the tutor, so the reason you said, if you go for a good tutor or a guidance, you are able to understand it easy. When you are able to understand, you are able to get an interest. When you got an interest, you are able to get a skill. When you got a skill, you are able to get a job. So another question, after when you need to ask it, for example, again, still you are jobless. Again, I'm unable to get a job. So, but here next time the question is, you have a skill. So now you can't say no skill. Again, this wise changes from the step. So by doing it multiple times, so you'll be knowing it where exactly you're going wrong, right? This is 5I technique. Basically, it's a root cause analysis technique. So basically, when we do use this in data science, why in the sense you are dealing with investigation of problems. So these techniques are needed. So I don't want to spend more on right now. So I'll be going for analysis after the break. Shall we go for a break and let's be back? Yeah, let's go for a break and let's be back around 11:30. All right. Sorry, 11:20, not 11:30, 11:20. All right. Hey, hi. Are you back, everyone? Once confirm me. It's right, Sima. You are right. Perfect. So the mind maps are helping you to, normally to understand all the topics, the statistics which we discussed for 1 hour, 1 hour or 2 hours. It's a bit tricky to remember all the things, right? If I'm not wrong, to remember all that in a single shot is a bit tricky. It's the connections are a bit tricky or difficult to remember. Now with a mind map, I think you can have that connection whenever you want it. So that would be easy for you to have a link, isn't it? So let's work on the mind map now. A bit more things we need to add it. So now here, you are able to take this sample concept. So how to pick the right sample, but here we can't place few topics like central limit theorem and all that. Why in the sense? Now, in order to make an analysis, I think we may use central limit theorem. So that is the root of it, but fitting here would be a difficult thing. So we use central limit theorem, but we can't fit it here, but that is the back end of our analysis. Got it? Why picking a sample is decided by the central limit theorem. So now here, let's go into this descriptive analytics now. So in this descriptive analytics, as we discussed on yesterday, we can do descriptive analytics for two things. What are the two things we can do descriptive analytics? What are the two things we can perform descriptive analytics? Hey, no man, I think forecasting. So one is with the descriptive analytics, you can work on what is that reporting. Is it right? So we are able to perform reporting, or we can call it as analysis, right? It's an analysis, isn't it? Reporting, is it comes into analysis or dashboards? Is it right? So your reporting or analysis or dashboards, all the three is your is more about, again, analysis itself. Is it a problem statement you are trying to analyze it? Isn't right? Yes or no? Please say yes or no over the chat, please. Is it right? Yes. So now I want to analyze about same real estate. So the same real estate analysis, can I represent it in a dashboard? The same real estate can be represented in a dashboard using 4 or 5. Absolutely, we can do it. So now reporting or analysis or dashboard. And another one with respect to this is like investigating phenomena. So, or I can say statistical testing, or I can say inferential statistics, right? So now in order to use the statistical what is it, statistical testing or inferential statistics, we will be going with what? Hypothesis testing. So now before going with hypothesis testing or anything, first we need to, in order to go for data analysis or etc. So what are the things we need to do? Any procedure we need to go for? So based on the purpose of analysis, so we are collecting the sample. That's what I'm calling it as data collection. Is that the first step? Data collection is the first step. So after collecting the data, what we basically do after collecting the data? After collecting the data, so data collection. And next thing is data understanding. Do we need to understand the data? After collecting the data, is it required to understand the data? So in order to understand the data, what we can do? So in order to, for example, if I want to understand my data, is it required for us to and have a domain knowledge? In order to understand the data, domain knowledge is required or not required? So in order to understand the data, we need to have a domain knowledge. So apart from having a domain knowledge, so is it required to understand about measurements? Understanding the features or columns. Is it required to understand features or columns? Right? So now, after understanding the features or columns, again, to understand your particular features and columns, do we use some of the mathematical techniques? Like, for example, to understand features or columns, what we can do, for example, I will be using the same. In order to understand these features or columns, can I do some EDA? EDA is called as exploratory data analysis. To understand the features or columns means like what I'm trying to do, I'm understanding the mean. For example, there is a salary, I'm understanding the average salary, or I'm understanding whether there are any outliers or whether there are any what is the deviation of the data. Is it required to have this basic basic EDA, basic exploring the data? Is it required? Yes, it is required. So now in order to understand the features or columns, so you are using EDA, so which is exploratory data analysis. So in exploratory data analysis, what are the things we have? It measures of central tendency. So in measures of central tendency, what are the things we have? It mean, median, mode, we have it. So now apart from measures of central tendency, so now do we check for measures of dispersion? Is it required to check measures of dispersion? Yes. In that, again, we have variance, standard deviation, range, right? So we need to understand measures of dispersion. So apart from measures of central tendency, measures of dispersion, is it required to check again, like in a visual format, do we check it? Do we use graphical representation? Do we use graphical representation? Like, for example, line plot. Why we use a line plot? To understand the trend. For example, if it is with respect to age, how exactly, or with respect to salary, or with sales, with respect to years, do we use line plot? How exactly the sales are happening across last 1 year to understand the trend, ups and downs. How the salary of a data scientist is going. Do we use trend? For example, what is the demand of data science from last 1 year? Do we use line plot? Yes. So we will be using line plot. And apart from line plot, do we use box plot? For example, box plot, we will be discussing it in later. Just I'm giving a rough. So we use box plot to understand distribution of data and to identify outliers. So what are outliers? What are outliers? What is an outlier? For example, if I'm saying there is a guy in our team whose salary is 80 lakh. I think, are you interested to know about? Can I call him as an outlier? Whose salary is 80 lakh per annum. Yes, he's an outlier. So anything which is extremely maximum or extremely, there is a guy whose annual salary is 80,000. Again, is it an outlier? Yes. So now box plot is used to understand the distribution. So now again, in the similar way, we have some more graphs. We call it as scatter plot. Scatter plot is used to understand relationship between two continuous parameters. So in order to understand the relationship between two continuous parameters, you are using what? You are using scatter plot. And again, in order to understand this, what is that relationship between two parameters? For example, how salary and experience are related. So experience and salary, both are continuous. Experience and salary, both are continuous. Yes, both are continuous. Now, in order to, now we have a graphical technique. Again, is it required to have a mathematical technique in order to understand the relationship between two parameters? Yes. So for that reason, we have correlation. Correlation coefficient. So which is denoted as small r. So this correlation coefficient is used to understand the relationship between two continuous parameters. Is it right? So in order to understand the relationship between two continuous parameters, we are using what? Correlation coefficient. And again, in order to go for the pictorial representation of correlation coefficient is what? The pictorial representation of correlation is what? The pictorial representation of it. Scatter plot, right? So now in the similar way, now you got a line plot, you got a box plot, you got a scatter plot. Now, for example, if you want to compare bar plot, for comparison between discrete and continuous data. Is it right? And in the similar way, we got histogram or QQ plot. So what is the purpose of histogram or QQ plot? To understand the distribution. So what is meant by distribution? Anyone are having the doubt? Kant, what is meant by distribution? Kant, anyone are having this doubt? What is meant by this distribution? Let me show you a small example what is meant by a distribution. So you may not have this doubt in your brain. Now you are able to see this graph. This is the data related to age. Able to see this? This is the data related to age. So the age is on x-axis. So 20 age, 30 age, 40, 50, 60, 70, 80. And y-axis is about what? The number of times each data is repeated, or any other graph. I think why it is, again, some people going to have the doubt, Kant, why it is in points. For that reason, again, let me use another graph. Yeah. Now you are able to see this age 30, 40, 50, 60, 70 age group. And you are able to see the count 10 times, 20 times, 30, 40, 50, 60. This is the count. Y-axis is count. X-axis is the age group. So now 50 age group people, how many times they are, for example, we got 50 age group patients are how many times available here? So which age group patients are more in count? 55 to 62 or something. This age group people are more in count. So now based on this distribution, so which age group people are more likely to come to our hospital? Which age group people are more likely to come to our hospital? 55 to 60 age group people are more likely to come to our hospital. Now, this is the distribution of all the hospitals or only this particular hospital? This distribution is related to all the hospital or only this particular hospital? This is basically this hospital. Okay, it is related to only this particular hospital. Absolutely. So now for what we are using, so histogram or QQ plot is used for what? To understand the distribution. So with respect to histogram and QQ plot, what we can use for distribution analysis? Box plot. So box plot is having additional benefit of what? Apart from understanding a distribution, we are able to understand what? Outliers. So even can I use scatter plot to understand outliers? Can I use scatter plot to understand outliers? Can I call this as outliers? See this? Can I call this as outliers? This one, can I call it as outliers? Yes. So now even in order to, can you use scatter plots to use again outliers? Absolutely. So even a scatter plot also can be used to understand outliers. Outliers. Clear? Able to understand? Everyone? So now all these are coming into which category? So measures of central tendency or measures of dispersion or correlation coefficient or graphical representation, all these are falling under which category? It comes into EDA. So what is the purpose of EDA? EDA is called as what? EDA is called as what? Exploratory data analysis. So now what is the purpose of exploratory data analysis? What is the purpose of exploratory data analysis? To understand the data. Perfect. So now with respect to this graphical representation, again, now you are able to understand the distribution. So what we can understand based on the distribution? Again, there need to be some metric, right? So what we can understand with the distribution? Is it required? So what this distribution is speaking about? Yes. So in order to understand the distribution, what we are doing? Normal distribution. So this normal distribution going to comprises of two types. What are the two things within normal distribution? Skewness, kurtosis. So again, in skewness and kurtosis, there are two types of skewness. What are the two types of skewness? Positive skewness, negative skewness. So again, in kurtosis also, you have the types. What are the types? Positive kurtosis and negative kurtosis. So now what is this skewness? What is this kurtosis? Let us have an understanding of skewness and kurtosis. So now For example, now histograms and QQ plots are explaining about what? Histogram, QQ plot, and box plot. They're explaining about what? They are explaining about a distribution. So now let me just go for a small, I think you're finding this explanation difficult, this mind maps, or you're able to understand it? Great, I think you are understanding. I will be sharing this mind map, Satvik. I'm building all this for you people itself. So what I can do by keeping it with me. Right. So now see, now this entire class, we will be learning about all this. No need to worry. So this entire training we learn, but we are building a mind map so that you will be having it. So I will be explaining at different junctions. For example, now, in order to understand this visualizations, do we know anything about coding? For example, I showcase some coding. Can you understand? Do you know coding? Not exactly. That's the reason we are just understanding the mind map. Once we got it, first we learn Python. After getting Python knowledge, then we learn visualization. There again, I explain these concepts. Again, there I take a data set. Then again, I explain these concepts, the correlation, dispersions, and all this. So you get connected. So these are all the things we learn this entire course. Okay. No need to worry on it. So the terminology is going to be new, but this is the connections you have it. All right. Is it clear now? Yeah. So now let us understand about normal distribution. What is normal distribution? This is what a normally distributed data look like. For example, if you take pricing of product in Amazon or salary of employees. So now if you look onto it in every company, so this y-axis is speaking about what? Is it right? Y-axis is speaking about count. So now when we are able to see at pricings of an Amazon, so we are able to see more people buy the product across moderate pricing products. Is it right? Most of the people buy products at a moderate pricing. This one, the center zone is moderate pricing. Is it right? Able to hear me? Once confirm me, able to hear me. Sorry, there is some network glitch today. Able to hear? Yeah. So this is called as count pricing. So now if you are able to look on to the customers who are buying, so now even if we take us, so people who are buying at very low price going to be high in count or low in count. For example, the data science course price is, for example, the same data science career transition, what we are offering right now. If we are saying it as 5,000, so most of the people going to buy it or they're going to doubt it. If I say 5,000, most of the people going to buy it or they're going to doubt it. So few people going to buy it. Mostly again, the audience can be freshers going to buy it. And when you are able to look at experienced people, they may doubt it. Why in the sense, why when people are selling a course around 1 lakh or 2 lakh, why these people are selling at 5,000 and they're giving a lot of services and all this, why at 5,000? A small doubt, right? And again, if the price is too high, again, people going to buy it or doubt it. Again, people may buy it, and as well as see, there is people are buying it. If you look on to all the scales, people are buying, but at low quantity, right? At low count. And if you look at the center position, moderate pricing, people are buying more. Even if you look at your wardrobe, the dresses, so you buy very low pricing dresses at very low count, and even very high expensive dresses also going to be in low count, but moderate prices going to be more in count. Is it right? Even when if you're able to open your wardrobe, is the same pattern? Yes. And not only with that, if you go to a company, very low salary paying employees, low in count, very high salary paying employees are also low in count, moderate salary people are high in count. In the similar way, in Amazon, low pricing, low in count, high pricing, low in count, moderate pricing, high in count. So that's what normal distribution states that. But is there any rule that every wardrobe or every company need to follow the same rule? Is there any rule or any pattern like that it need to be in the same way? If the pattern is like this, so what exactly normal distribution says that when mean is equal to median is equal to mode. When all the three things are same, then we call it as what? When mean is equal to median is equal to mode, we call it as? Let me take a very simple example. What we call it as when mean is equal to median is equal to mode? We call it as normal distribution. So now there is a person who's coming to office timings OT. Every day he's coming to office at 10 a.m. So what is the mean of this particular person? What is the mean? We are learning about mean. What is the mean? Sum of values by number of values. Is it right? So now all the 10 values, for example, 1, 2, 3, 4, 5, 6. So 60 divided by 6. So the mean is 10. So what is the median? You need to arrange the data in ascending order or descending order and pick the center value. What is the median? 10 is the median. So what is the mode? Mode is calculated as most occurring. So which value is most occurring? So all the three are same or not? They are same. So now how you calculate variance? So variance is calculated by sigma square is equal to xi minus mu whole square by n. So what is mu? 10. What is xi? First record 10. So the variance is how much? Variance is how much? Variance is 0. So now when you are able to see the variance, at what time he is able to come on next day? The variance is 0. Every day he is coming at 10. At what time he is able to come to the office on the next day? So at 10. So now when the variance is very low, are we able to make statement about the future? The predictability chances are increasing. Absolutely. So now when you are collecting a data of normal distribution, so the chances of predictability are what? When your data is collected in a normally distributed format, the chances of predictability increases. For example, if the data is not properly distributed, then the chances of predictability increases or decreases? So it decreases. So now, but that's what statistics says that. But every time getting a highly distributed data, is it possible? Getting a very good normally distributed data is possible every time in real time? Not exactly. So even though the data is not normally distributed, you want to make a prediction, right? That is the challenge we face it in the real time. So now let's change the data. Now it is not, let me erase it. Now we collected the people around 10. Now let me change the same example. Now a person office time, he is coming to office every day, one day at 10, one day at 9, one day at 11, one day at 12:30, one day at 11:30, 8:30, one day at 8:30. Now the average, what is the average? Now can you make a statement about future? For example, once calculate me the average 10, 9, 11, 12:30, 11:30, 8:30. So we can say like 10, 9, 11, 12.5, or we can say 12.3 or something. It's up to you. So once give me that number. So on an average, he is reaching to office at 11. Is it right? On an average, he's reaching to office at 11. Is it right? For example, every day is he reaching to office at 11? Is he reaching to office every day at 11? No. Now the variance is increasing or not? The variance is more for this data. So now can you make a statement about at what time he's able to come to on the next day? No, right? So when your data is not following any type of distribution, it's going to result in less predictability. So in order to increase your predictability, so we measure it if the data is normally distributed. So then Kant, what is not normally distributed? What is a skewness? Just imagine, for example, I'm very poor and I'm buying all the products at low price. Is it a wrong thing? This is called as skewness. Is it a wrong thing? So I'm very poor, so I'm buying all the products at low pricing. That's not wrong. That is the tendency of the behavior. So now the next product also going to be from which zone? He's more likely to buy products at which zone? At the same pricing, right? For example, if a customer is he's so rich and he want to buy all the products at high pricing, then he's more likely to buy which products? So this is called as positive skewness and this is called as negative skewness. So the skewness is what? Tendency towards either any one side. So it is not exactly sticking onto the center. It is pulled to either a left side or the right side. We call it as skewness. Apart from skewness, you have one more technique or one more approach. We call it as kurtosis. So what is kurtosis? The count of data. For example, the data is very less collected. This is how the distribution is. This is called as negative data. Then if you collect a least amount of data, does it alter your analysis? If you collect a very least amount of data, the count, if you collect it, does it alter your analysis? Does it alter your distribution? Yes. So the measure of how much data to be collected is called as kurtosis. You can understand in a high level. The deeper things we do it in the later classes. So just in a high level. For example, if you cover more data than what is required, then also does it alter the analysis? If you cover the data more than which required, which is called as positive kurtosis. The very simple example of this kurtosis is, if you are, it is there in chemistry. You take water and dilute sugar into it. If you are taking very less amount of sugar, so the water going to taste like sugar or it going to still taste like a water? Very less sugar you added it below its dilution point. So we call it as still a water. So we call it as what? Under saturation. Is it right? In lines of chemistry. Is it under saturation? For example, you have taken more sugar than the available water. You are still able to see the sugar granules. So for that reason, what you do, you try to take water and the sugar on a pan and you boil it. By boiling it, it is able to dilute more and more sugar into it. But when you are tasting it and when you are able to place it under a room temperature, we are able to see the sugar granules going to be formed. Anytime you saw that while you are doing some sweets or anything? Yes. So which is called as oversaturation or supersaturation. Is it right? If you are able to collect exact amount of sugar and water, we call it as saturation. So these are the three levels. For example, Kant, when we are collecting less data, what happens? Your analysis is going to be right. It's going to be right when you collect less data. No. When you are over collecting the data, again, your analysis is going to be right. Means like overthinking, or over analyzing it. Again, you are doing over analysis. Even if you do over analysis, can you take a decision? So the right amount of decision is needed. So now, Kant, how can I know I collected the right sample? Anyone have this doubt? Kant, how can I know how to know the right sample? So the kurtosis is helping us to identify the right sample. If the kurtosis value is equal to 0, then you collected. If kurtosis value is equal to 0, right sample. If the kurtosis value is negative, then you collected less data. If the kurtosis value is positive, then you collected more data, right? So now we will be learning about them when I'm explaining the coding, not right now. So let me showcase you even in the coding. You're able to see skewness kurtosis here, skewness value. There is a negative skewness kurtosis. There is a negative kurtosis. Able to see this? So we discuss it in later classes, not right now. When we learned about programming, then I will be explaining these concepts. Now in a high level, are you able to understand this? In a high level, able to understand this? Skewness, kurtosis. So skewness and kurtosis in a very simple note. Skewness is speaking about what? Skewness is speaking about what? Tendency of data, on which side your data is inclined to, whether your data is inclined to lower side or whether your data is inclined to higher side, is spoken about your skewness. Is it right? Inclination of your data is explained by skewness. So how much data we collected, how much sample we collected is explained by whether we collected more data or less data, or exact amount of data is explained by kurtosis. So the amount of data is explained by kurtosis. The inclination of the data, whether it is inclined towards left side or right side, is explained by skewness. Clear? So now the skewness kurtosis, this techniques comes under which category? They comes into analytics or they comes into EDA? They come into EDA. Absolutely, they comes into our EDA, exploratory data analysis. So once you're able to understand this, we'll be discussing about them in depth while we are having a good knowledge on programming. Not right now. We will be having in-depth analysis. I take a real-time project and I explain it so you get a clear picture of it. So is it clear? Once confirm me. So once you got a better understanding on the data, now without a data understanding, can you clean the data? Now you got a very good understanding on the data. After having a good understanding, what you do? After having a very good data understanding, then you try to perform what? Data cleaning. So after having a data cleaning, now you are able to understand the data, you are able to clean the data. Then after having a cleaning, then what you do? Then you perform analysis or pattern understanding. Is it right? So then you go with analysis or pattern understanding. Clear? So now without having this understanding on the data, can you directly go on analysis and pattern understanding? Without having a deep understanding on the data, can you perform data cleaning? Is it possible to do data cleaning? No. You are able to understand outliers, you know the business problem, so you can do cleaning, or you can do pattern understanding or analysis. Clear? Once confirm me. So after following these steps, either you go with pattern understanding through what? We are doing analysis or pattern understanding through what? Through reporting or through dashboards. In case if you want to perform inferential statistics or hypothesis testing, then after data cleaning, you push it to what? after data cleaning if you want, based on the problem statement. Either you go with either this or you go with hypothesis testing. In hypothesis testing, there is nothing like train data, test data. So it is like descriptive. In descriptive, we don't have anything like train data or test data. So either you go with, if your goal is to build a report, then after data cleaning, you build the reports. Or in case if your goal is like to investigate a phenomena after data cleaning, you go with hypothesis testing. Clear, right, everyone? Data cleaning, I showcase it while we are doing it, Seema. Now we can't explain data cleaning. To explain data cleaning, we need to have the coding. With coding, we do data cleaning. Okay, yeah. Once see this, now is all this concepts clear? The connections of the statistical things. So any doubts you have on this, please do ask me so that I can just clarify you. Any doubts if you have, you can just ask me. I will be uploading this link on your dashboard. No need to worry. So let's go for complete understanding. Let's do an overview of this concepts which we discussed. So what we discussed on all this. All right. So now today what we covered is like we started with statistics. So Pawan, this is not, it's an overall map. Again, few things going to come into the play, Pawan. Okay. Again, within there is a probability distributions I haven't added into it. It also need to come. So we will be discussing later. Okay. All right. So now today we started with statistics. Now I'm giving a summary of our today's class. So we started with statistics. So statistics is a discipline of the way we are doing our analysis. So now we started with the definition of our data. What is the data definition? Which is set of measurements on set of recorded values. So again, in that we understood the different data types. We got a discrete data and a continuous data. This is very important. Based on the type of data, the way you do analysis changes. So now again, data properties. So we have two types of data properties, uniform data and a random data we have it. So when the data is random, the goal of a data analytical person or the goal of a data scientist is to understand the randomness. So by understanding the randomness, we are able to make a statement about the future. So how we are able to understand the randomness? Through our analysis. So in order to start with our randomness or through all this, from where we got this randomness? We got our randomness from this data sources. If the data is experimental, we may not have much randomness and it not demanded research or analysis on top of it. But when the data is observational, for sure, the data going to be random. So when the data is random, yes, we need to understand it. So we are performing analysis. So how we can perform analysis? So in order to perform any analysis, we don't have the access to the population. So we need to access the sample. So why we are analyzing sample and how we can make a statement about population is with the help of central limit theorem. So central limit theorem states that, so the population of mean is equal to the sum of sample means or average of sample means. Based on that theorem reference, we are taking sample and we are trying to perform the analysis and we make the projections on top of the population. So how to pick a sample? In order to, the entire population analysis is ruled with respect to the right sample. So how we can collect the right sample is with the help of our SAC, statistical analysis consideration. So based on the statistical analysis consideration, so we are able to identify, so purpose of the analysis, document the questions, identify the right population of interest, and collect based on the three things we are able to collect the right sample. Once you collected the right sample based on the problem you have, for example, if your goal is to just analyze about the past, you go to descriptive. If your goal is about to make a statement about future, you go to predictive. If your goal is to make a statement about prediction plus an action, prescriptive. So now my goal is only about making a statement about the future, not future, about the past. So now what I'm trying to do is I'm going with a descriptive analytics. So in descriptive analytics, we have the two things we can do. One, we can perform reporting, or we can investigate the phenomena. So now here the goal is just to perform reporting. We are not doing any investigating of phenomena. So we are going with reporting. So in order to start with reporting, or in order to go with inferential statistics or investigating about about the past or a phenomena, we need to collect the data. We need to understand the data. So in order to understand the data, first thing is we need to have a very good domain knowledge. After having a domain knowledge, we need to understand the data which we collected, means the columns or the sample, we need to understand it. So for that reason, we perform EDA, exploratory data analysis. So in order to perform this exploratory data analysis, we have these are the steps. We need to perform measures of central tendency, measures of dispersion or correlation coefficient, normal distribution, and graphical techniques. When you are going with the measures of central tendency, again, you have three types: mean, median, and the mode. In case if you are going with measures of dispersion, you got variance, standard deviation, and the range. So the purpose of correlation coefficient is used in order to understand the relationship between two parameters. If I want to understand whether the two parameters, salary and experience, are related, to understand that, I can use correlation coefficient. And to understand the nature of distribution, I can use normal distribution. So in that we have types: skewness, kurtosis. Again, within skewness, we have types: positive, negative, positive kurtosis, negative kurtosis. And apart from it, for all this above mathematical techniques, we have the graphical techniques. To understand the trend of the sales, or to understand anything with respect to time, I use line plot. To understand the distribution, I use box plot. And to identify the outliers, we use box plot. And to understand the scatter plot, we use again, scatter plot is used to understand the relationship between two parameters, two continuous parameters. And to understand outliers, yes, scatter plot. Bar plot for comparison between discrete and continuous. Histogram, QQ plot, or to understand again distribution. So these are the things which we discussed today. Got it? In a very simple summary. Now, as I said, this is the brain of descriptive analytics. So now, without this theory, can you do anything with coding? No. Now, even if I showcase the scripting which I provided, all these things, distribution, is it a concept of theory which we discussed right now? Is it a theory which we discussed? So for example, you are able to see skewness and kurtosis. Is this the theory which I used it right now? Now you are able to see describe. It is also distribution. So now you are able to see mean, standard deviation. They are also concepts of the theory which we discussed. Line plot. Is it a theory we discussed right now? So now whatever we are doing right now through coding is driven with respect to this theory. Now, this EDA can be called as analysis, or it is only data understanding phase of, is it a final analysis or is it only the beginning stage of analysis? EDA. It's only a beginning stage. What is the motto of this EDA is to understand the data you collected, to understand your features, to understand your particular samples. So now once you got the good understanding, then you perform cleaning. And after you got cleaning, what you do, now you start going with a proper pattern understanding. Got it?